A black Ethernet cable snakes from a wall jack across a floor and stops a few feet short of a laptop. Someone could add another cable, tape it down, and hope no one trips over the modern world. That was the hidden problem at the edge of the internet. The network could cross oceans and buildings, but the last few feet still ended in plastic. Wi-Fi did not invent the internet. It moved the last visible cable into the air. It was not the internet itself. It was the local radio bridge between your device and the wired network hiding in the wall. Once that bridge worked, the internet stopped feeling tied to one machine and started following ordinary life around the house. Long before home routers blinked on bookshelves, researchers had to answer a strange question: how do computers take turns in the air? In the early 1970s, the University of Hawaii faced a physical networking problem. Computers were expensive, the islands were separated by water, and cables could not simply be dragged from campus to campus. Norman Abramson and the Aloha Net team used radio to send computer messages as packets between islands. It was not Wi-Fi, but it proved something Wi-Fi would need. The air could carry computer traffic if machines learned when to speak, wait, and try again. A wire feels private because you can see where it goes. But a radio channel is shared. That made wireless networking less like mailing a letter and more like speaking in a crowded kitchen. Too many voices at once, and the message breaks. The next breakthrough looked less like invention and more like permission. In 1985, the FCC opened parts of the radio spectrum for unlicensed spread-spectrum devices. These were common spaces, not protected lanes, and microwave ovens and industrial equipment already lived nearby. But access to those frequencies let builders experiment without asking for an individual license every time. The bargain was simple: keep the power low, follow the rules, and share the air. Wi-Fi would grow inside that bargain. By the late 1980s, NCR engineers in the Netherlands were working on WaveLAN, a practical system for places where wires were awkward. A warehouse scanner, a cash register, or an office computer could connect without pulling cable through every wall. The early equipment was expensive and specialized, but it made the shape of the future visible. Sending a signal was only part of the challenge. The harder task was making one company's signal understood by another company's machine. Without agreement, every device was its own island. So the story moved from radio hardware to conference rooms. Engineers, companies, and standards groups had to turn wireless networking into a common language. In 1997, IEEE published the first 802.11 wireless LAN standard. The name was awkward, but the result was practical. Laptops, wireless cards, and access points could finally be built to work together. Other breakthroughs were also being folded into the larger system. In Australia, CSIRO researchers worked on the indoor radio problem, signals bouncing off walls, furniture, and rooms until the message blurred. The foundation mattered, but a written standard alone could not assure buyers the two products would actually connect. In 1999, the Wireless Ethernet Compatibility Alliance formed to test products and prove they could work together. The name Wi-Fi gave the system a handle. Certification gave it confidence. That was the quiet human achievement. Not one inventor, but agreement strong enough for strangers to build on. Then came the part a normal person could understand in one glance. In 1999, Apple introduced AirPort for the iBook, making wireless networking easy to understand. The demonstration was almost comic, Because the point was so clear, the computer stayed online without a cord. For once, the magic was not hidden in a data sheet. You could carry it across the room. The cable had not vanished from the world. It had moved backward, into the base station, the wall, and the service provider beyond the house. But to the person holding the laptop, the difference was immediate. The edge of the network had moved into the room. In the 2000s, Wi-Fi moved from offices and airports into kitchens, bedrooms, classrooms, hotels, libraries, and coffee shops. The router became a tiny household lighthouse, blinking near the modem while the family moved around it. Laptops escaped the computer room. Printers found the network without a cable. Game consoles, tablets, speakers, cameras, thermostats, and phones began expecting the air to answer. The Wi-Fi icon became a tiny weather report for modern life. Full bars meant the room was cooperating. One bar meant the invisible hallway was crowded, blocked, or just in a bad mood. Every generation has tried to solve the same old problem with better manners. More devices want to speak at once, and more walls, neighbors, appliances, and routers get in the way. So Wi-Fi learned to use new bands, wider channels, multiple antennas, and better ways of dividing attention. Wi-Fi 6 was built for crowded homes and offices, and Wi-Fi 6E opened more room in the 6 GHz band. Wi-Fi 7 pushed the idea further, with lower delay, multi-link operation, and better ways for devices to compete at once. And the next wave points beyond speed. Reliability, when the room is crowded, sensing what is happening in the space, positioning devices more precisely, protecting privacy, and preparing security for the next era of computing. A phone wakes, a router listens, packets move, and life keeps going. The strongest network is often the one that slips out of attention. But convenience brought a new worry. A cable usually stops where the cable stops. A radio signal can reach the apartment next door, the hallway, the street, or the parking lot. Early Wi-Fi security tried to make the air feel private, but the first system, WEP, was weak. Later protections, including WPA, WPA2, and WPA3, made security a central part of wireless life. Public Wi-Fi still carries that lesson. A shared signal is convenient, but it is still a public place. Today, Wi-Fi is most visible when it fails. A frozen video call or a buffering movie can suddenly make a connected home feel primitive. That irritation is also proof of success. Wi-Fi has become so ordinary that silence from the router now feels like a household tragedy. But wireless never meant wire-free. Behind the router are cables, fiber, switches, servers, power, standards, maintenance, and people keeping the network alive. What changed was the final distance between that infrastructure and the person using it. The person no longer had to stay where the cable ended. Wi-Fi did not make the internet weightless. It made the last connection feel ordinary enough to disappear. From tangled wires to rooms full of signal, you are always welcome here. At Illumentary,